I think we should get started. So I know some people are new here, so I'm gonna give a bit of a recap of the first lecture in a bit, but don't worry about that. Let's just launch in to a motivating question here, which is, does education cause an increase in earnings? So this is something that I think many of us think is true, right? Our priors, what we generally assume about the world, is that this connection is causal. And suppose I told you that the data has this highly correlated relationship where many people who do have high amounts of education also have high earnings. What does that tell us about these two variables and the link? So honey, I'm gonna call on you because I know you and I can just call on you. And I know your dad.
Oh yeah, that's fine. I was gonna try to raise my hand.
Yeah, you can just talk. That's fine.
Okay. So it would just tell you that there's a relationship because correlation doesn't mean causation.
There it is. Music to my ears, right?
Yeah.
So yeah, spot on. And this is such a deep problem in society. If you see articles written online, I'm sure you've heard people claim, that something causes something else. Oh, I ate something and I played incredible tennis. Like there's like all sorts of these kinds of things happening every day where things might be correlated. Like you might find that, oh, people who are vegetarian are performing well in some sport, but that the causal link is very hard to pin down. And that's kind of what we're trying to do in this course, is understand causality in a deep way, because that's the only way to get to any truth. So let's talk about this question about education and earnings. So there is a paper, the groundbreaking paper that was published in the early 90s that did attempt to show a causal link. And they did it without an experiment. So I'll explain what happened here. So the underlying problem, if you just have data on education and earnings, is that there might be a third variable. We call this a confounding variable that is affecting the decision to go to college or to have higher educational attainment. And this variable, there could be many variables, but one kind of obvious one that you might understand is intelligence or ability, right? Those with higher ability, and I'm using ability because ability is more of a general term than intelligence, but you can think of it as the same thing. It's the higher ability people who are going and choosing the higher education. And thus that is what's driving the higher earnings, right? So in a sense, it's not the education that's causing the earnings, it's the ability, right? Now, what we want is we want some way, ideally in an ideal world, we would run a very sadistic experiment where we have two groups. We give one group a lot of education and the other group no education. Of course, that would be unethical and prone to many problems. So we're not going to do that. So this is kind of the fundamental problem in economics. Many ideas we want to test aren't able to be experimented on, right? So the idea behind this paper was to use variation caused by mandatory schooling laws in the US, which require that students enter the school year enter the school, in the calendar year that they turn 6. And they have to stay in school until their 16th birthday. So take 2 friends who begin school in August 2006. Margie is born on January 1st, 2000. Basil is born on December 31st, 2000. So they're almost a year apart difference, but both are in school, starting school at the same time. Now, at age 16, how much schooling is each one going to go through? If my math is right, should be 9 years and 10 years, 9 and some change, right? And the interesting thing here is at age 16, Margie can drop out, right? But Basil can't drop out until another year, right? Because he has to turn 16 to be able to drop out. So this variation here on when people were born creates a kind of quasi-experiment, because some people in the age cohort are given more education and some are given less. You following me? So here is the graph they show that motivates this. That's what I just said. Take a look at this. So on the y-axis, we have the years of completed education, and the x-axis, the year of birth, and the numbers below these points are the quarters that the individuals were born in. And so you see people in quarter 1, that's like the Margies of the world, they have systematically less education than the other people in their cohort because of what we just talked about, right? That some percentage of people are going to drop out because they can't. But basically the people who are very similar to them but can't drop out are getting more education, right? So the control group here, if a control group in quotes, right? The control group is are the Margies of the world. If we're going to say that this experiment is testing an increase in schooling, and the Basils of the world are getting more education. So the main results of this paper showed that, and this studied men, because of course at the time only many men were going to school, which is of course a problem. That's a whole nother topic for another day. Found that men born in the first quarter have around 1/10 less education than their peers and earn 1% less than their peers. Now that might not sound like a big number, but remember, we're only looking at 1/10 of the difference in education, and we're finding a 1% increase. So $100,000 a year, if you're making that, that's $1,000 difference every single year. And remember, only 1/10, that the experiment here is only 1/10 difference in education. But more than the results, the paper really made its hay because of this methodological idea to compare the cohorts in this quasi-experimental manner. And so every quasi-experiment, or I mean, this is actually true even in experiments, but it's very clear in quasi-experiments, is there's an assumption at play, an assumption that argues that this quasi-experiment is very close or can be treated as an experiment. And the idea here is that the quarter of birth should not affect income directly. Like there shouldn't be some reason that people are saying, oh yeah, I want to have my kid born in such and such month, for other things. Or maybe, there are certain socioeconomic reasons why some parents are having kids in certain months. That should not be the case. And the authors provide some evidence for that, but some of this has come under critiques recently, but that's beyond the scope of this class right now. That would be a whole hour-long conversation. The main point here is that causality is very hard to prove without an experiment, but we're going to try. That's the goal. Any questions on this? So I like keeping this image of in the head, these arrows and what is affecting our outcome. So our outcome is the y variable, right? And you can just think of this generally all the time, this kind of directed graph, it's called. Because if we just have data on education and earnings, which is our y, we're missing the unobserved factors, and our estimates will be inconsistent. Okay. So a bit of a roadmap. I'm going to give a recap for those who missed the first class. You missed a lot. It's going to be hard for me to recap an hour-long class in 5 minutes, but again, I'll try. Then we'll talk about some more big picture philosophical questions about what are we doing here. And then we'll discuss the in utero studies, which I think are super interesting. They're terrible that they're happening, but from a scientific perspective are fascinating windows into, basically they're the best version of quasi experiments that you can get in observational data. Okay, so we talked about what this class is. What are we doing here? Basically, I've constructed this off of a class that I taught in high school, now ages ago, which was an intro to social science. It was for those who are familiar with the IB program. It was theory of knowledge was the class. And so I basically structured it as an introduction to social science, but throughout, I want to highlight the methodological tools, because of course that's what separates many economics papers for sure, which is what I apparently know more about than other things. Yeah, and why do we need this? Why should you even be here? Well, I think the understanding of data in 2021 is profoundly important. If you don't have a sense of what data means in a variety of contexts, and there's data everywhere in every single profession, you're probably not going to be an economist. Maybe you are, but even if you're going into medicine, you're going into law, likely that you're going to come across data in some form. Patient records or aspects of a lawsuit. Someone could be arguing that one architectural firm ripped off another architectural firm's stairs, for instance, and you might have data on one firm's website and the information about the stairs on that website. And so you want to have flexibility with your knowledge of data and be able to understand what's going on, because without it, you're kind of just flying blind. And if someone else says something about the data and you can't analyze it, then you're kind of up shit's creek. So yeah, and in this day and age, I think combating misinformation and falsehoods is even more important than when I was younger. At least it seems like that, but maybe I'm just misperceiving. and you can always arm yourself with facts, right? Like I think that's like one of the most useful reasons why we learn, why we read. But if we don't have a problem solving apparatus, you can't approach a new fact and a new claim. You kind of just have to say, oh, well, I don't know about that. You know, if someone, and this will often, especially when you get older, someone is going to try and sell you something based on a claim. And you're like, oh, this product does this. Now buy it. So you need to be able to analyze the claim. So as Sahani mentioned, this is code. This does not equal yeah. So correlation is not causation, right? Experiments are how we get to causation. Good experiments, of course. If you have a bad experiment, then you're not going to get there. Now, experiments are rare. We talked about that because of a lot of questions are just completely unethical or just too costly to run. Now, we talked about a few experiments in economics that measured discrimination. Does anyone remember how that went down? So, honey, I guess I'm gonna ask you again. Okay, if you don't remember, I'll explain.
Yeah, I don't remember. Sorry.
Okay. So we talked about this paper where these authors wanted to measure discrimination in the hiring process. And so what they did was they created 2 batches of resumes that were identical. Okay, so each one had a matching resume. And the only thing that was different was the name at the top of the resume. And so some resumes had names like Lakeisha and Jamal, which are traditionally Black names. And the other pile had names like Emily and Greg, which are traditionally white names. And they sent all of these resumes out to many different firms and measured. Their measure was the callbacks that were received. And they found that the white names received 50% more callbacks than the Black names. And these are for identical resumes. So that was a pretty stunning result. And the experiment is pretty ironclad. And this has been replicated now in different settings with this method. But I find that experiment very powerful, and the results very disheartening, sadly. Okay, so again, now we'll ask some big picture questions because we have to establish some sort of baseline here. How are we doing on the time? Can't view the time here. Okay, we're doing good. Okay, so what's the point of economics? And then many people might think economics is about money, is about the stock market, but we don't really have that view here. It's more a framework to help us analyze choices using this benefits minus the cost idea. When we traditionally take an action, like I'm going to drink this water because the benefits outweigh the cost, because I'm thirsty, and that's why I'm doing it. It might sound very trivial, but remember, this can expand to every single decision. So we're talking about decisions about divorce, decisions about having children, et cetera, et cetera. So I find this framework supremely powerful. And of course, when I was taught it, I was like, oh, that's my stuff. And most interestingly, it helps us predict a change in one aspect of the decision outcome. So the common idea is either having a policy change, which could be a imposition of a tax or an increase in the minimum wage, and understand the outcome. And for a long time, economics was purely theoretical, like basically all of like the early 1900s. And they used sort of toy models to argue that what would happen with the increase in the minimum wage is you would have a big reduction in employment. Because if you think about it in just a very simple way, a business operates under two sort of inputs. One is labor, which is the people they're hiring, and capital. Capital is everything else. So the building, the technology, et cetera, et cetera. And so if we just increase the cost of labor, that's what an increase in the minimum wages, what is a business going to do? They're going to shift their inputs to capital, right? So if you see in Walmart nowadays, in my hometown in Florida, there are no people at the cash register anymore. It's completely, you have to just go and self-checkout. So that's all the capital, because the cost of labor is going up. So this is a kind of ironic thing that many people arguing for an increase in the minimum wage, because of course they're trying to solve the problem of poverty, which we all want to solve, trust me. But if you don't think through the consequences, you actually end up getting to a worse outcome than what we desire. So to me, fundamentally important idea. And this is even, remember, we're talking about even just theoretical understanding. We'll get to the data in a second. So statistics is a piece of this, right? I'm not going to delve really deep into statistics just because we don't have time if we want to like cover anything. But there are some ideas that we have to understand, because statistics helps us analyze data, and it helps us do statistical inference, which is we have a sample, we did some sort of test or experiment or quasi-experiment, and now we want to infer something about the population. We want to learn, right? Now, econometrics, very fancy sounding word, it's basically just the linking of those two previous things, right? It's asking us how to measure these economic choices. And remember, we're not talking about just things about money and income. We're talking about social choices like divorce, marriage, even crime, and health choices like whether to get vaccinated or not. And the point is we want to find out these causal effects. We want to find out if an increase in schooling does cause, there should be a cause in there, sorry, an increase in earnings. Because remember, theoretically, we could argue, oh, it's just motivated entirely by this third variable, ability. And schooling actually does no part in increasing the wages, right? But once we look at the data, then we can find out the truth. Okay. And data science has gone through, a huge kind of revolution in the last 20 years. It's super hot right now. Like everyone under the sun wants to take a data science course, and they're hiring many data scientists in many companies. And the main difference is, I would say the methods aren't really different. Like these ideas in statistics and econometrics with causality have been known. But now the data has gotten incredibly high quality, and the computing power is gotten way high. And so anyone with a laptop can basically do very sophisticated analysis when 20 years ago you needed like a academic machine. That's like the main difference. Okay, any questions before we delve into these in utero shocks? I'm going pretty fast here, so I'll wait. Okay, so let's have a bit of a discussion here if we can. So why do you think these in utero shocks might be really good examples of quasi experiments?
Because I think they were trying to limit some of the confounding variables, so they were able to measure. Well, not only did they have really specific data, and it ranged for a really long time, they were able to separate and compare children who, or like the subjects who experience stuff within the womb versus afterwards. So it was really nicely divided, and the data was also super specific, like how big their heads were to like the medication intake and stuff like that. So
yeah, I mean, the data in that paper, we'll talk about that paper in detail in a second, but in general, the main thing there that you said is these in utero shocks are random, right? They're happening without sort of prior knowledge. So that randomization is what makes an experiment, right? If we didn't randomly divide the subjects, then the experiment would not be valid, and then we wouldn't break the correlation with all sorts of other variables. That's the beauty of the experiment, is the randomization. And so here we're saying that the groups of pregnant women that we're comparing, one of them gets randomly affected by these in utero shocks and the other doesn't. So that's kind of what's beautiful here. See, it's much easier to argue the randomness here than in remember the paper we talked about with the schooling, because there we're talking about the quarter of birth, and there could be some seasonality there, we don't know, but here it's very hard to argue, because they specifically look for sort of sudden shocks. Like they're not like looking for ones that are really predicted. Okay, and this is a whole literature now about the in utero shocks, and there have been large shocks studied. So the Rwandan genocide in 1994, a bunch of terrible things. This is just like a slide of terrible things. But these large shocks provided researchers a way to study these effects. And as you'd expect, there were all sorts of problems with these children, lower educational attainment and other things. But what I found very interesting is even milder shocks have these effects. And there are a bunch of papers that have analyzed Ramadan fasting, and they found that this fasting, because of a decrease in nutrition to the fetus, causes a range of these problems here: fetal breathing, fetal heart rate, admission to special care unit, et cetera, et cetera. So it's not just the large shocks. It's even mild shocks have these problems. So let's talk about this paper. So when you're reading one of these papers, I always think it's good to zoom out and then good to zoom in. So zooming way out, what's the problem here? that the researcher are after. Tahani.
Okay. I guess just trying to make the world a better place by limiting mental health. They're trying to understand what causes it. So
yeah, mental
like,
health. I think
yeah.
is a big picture problem here, and they do even talk a bit about poverty, right? So I would say those are the big picture problems. Now, what about the detailed? How like zoomed in? Can you give me? Let's see if I can call on someone else here, because these guys don't have their video on, but I'm gonna ask someone here. Arav, are you there?
Yeah. Okay. So I think in terms of a detailed aim, I think they're looking for the cause of like like adverse, like the adverse effects of. Okay, maybe not. I mean, like basically they're trying to study the cause of such mindsets and such mental health because of the like amount of increase in medication that has been happening over the last few years. So I
Mhm.
think that is what in detail the research is about.
So just I think you slightly misused the word. So remember that the effect is what they're looking at is the mental health. The cause,
Oh yeah.
right,
So they're looking at the cause. Okay, I
of
understand.
the shock, right? The maternal death is the that's the cause,
Yeah.
right? And the effect is the mental health, right? And so if you want, I would, if I were you, just kind of copy this kind of framework for every sort of paper you look at, where you have the big picture, zoom out, zoom in to the detailed research question, and then the econometric strategy. So this is important here because we're not only dealing with experiments. Of course, if this was like a biology class or a physics class, everything is the same. Everything is an experiment. And you'll see this is where there's a bit of art to social science, because there are gradations of, I would say, there are gradations of solidity in a quasi experiment. What do I mean by that? Let's again compare this quasi experiment to the other one regarding schooling. So I think this is much stronger in terms of its validity as a quasi experiment than the ones on schooling. And why is that? Because I think the argument of whether a maternal death occurs is more likely random than the quarter of birth in a cohort. I can imagine some sort of reason. Again, I don't know whether this is true, and there are people who have claimed this. This is a minefield for another day. That, oh, there are some seasonal reasons why some people are having kids in certain times. You know, you can imagine that being the case, but it's very hard for me to imagine this lack of randomization of the death in the family. Now, one of the coolest things here, again, this is a strange sort of topics because they're studying like something so terrible, but they're coolest in terms of the research sense, is the fact that they have data on how close the family member is to the mother, where the farther apart in the sense of a family tie, so losing a grandparent compared to losing a parent, that kind of thing, should give a different amount of stress, right? Where the farther family member in the social tie sense will give less stress than the, say, the mother, father, or sibling. And the effects are in conjunction with that that hypothesis. So that's one of the coolest things about the paper, is it's not just that the family shock has this effect, it's this gradation that you can see with the social ties. So here they're just showing the effect of these of this death on I think it's birth weight, yeah, on low birth weight. And so the way to look at this graph, you might wonder, why are there these 3 lines here? There is the main effect, which is the mean, right? The average, the arithmetic mean. But there's what we call a confidence interval. Okay, and this is like some statistics knowledge we have to all understand. Is a confidence interval tells us how likely our effect is to be different from our sort of null hypothesis. I'll give you a completely different example to make it clear. Let's say we're testing a theory that Gatorade makes plants grow more than water. Okay, and I tell you that I give 50 plants Gatorade, another 50 identical plants water, and the plants are growing after a month, and I find that the average of the Gatorade plants is 7 feet, and the average of the water plants is 6 feet. So the Gatorade plants are higher. So does that mean that the Gatorade caused an increase in growth above the water? Anybody? Aditi, how about you? We haven't heard from you.
I would assume, yeah.
Sorry?
So Gatorade is 7 feet and water 6 feet, right?
Right.
Yeah, then I think you would assume that Gatorade causes it to go taller.
Anybody else? So it's a bit of a trick question. The answer is we don't have enough information to say. And the reason is I haven't given you any idea about what's called the standard deviation. Okay, and the standard deviation is just how much dispersion is there in the data, and the standard deviation helps us construct a confidence interval. So I'm just going to explain it like this. Imagine out of those 50 plants, the deviation was very wide, meaning there were many plants that were sort of 2 feet tall, 3 feet tall, and then there were many that were, 12 and 13 feet. And that's basically the same for the water plants, but the means are slightly less. So the overlap in the distribution is very similar, right? So in that case, we would not be able to say that the Gatorade caused an increase in the growth, because the standard deviations are very wide, and essentially that difference could just be due to chance. You're following me? But now I'll give you a different scenario. Imagine, of course, this never happened in reality, but let's just say the 50 plants, every single one of them was 7 feet exactly. And the other one, the water plants, every single one of them was 6 feet exactly. So now there's no overlap in the distribution, right? Now we can say that the Gatorade caused an increase. So this idea of standard deviation is a crucial idea. And basically, if you've seen the normal distribution, you've seen this bell curve. This is what we're talking about, where traditionally, these are some numbers that you'll see in a statistics class, and it's good to just sort of know them, that a standard deviation above the mean and below the mean contains 68% of the data in a normally distributed variable. And many things are normally distributed, right? Like people's heights, people's weights, plant height, plant weight, etc. Many things are normally distributed. So I'm saying 68% of the data is in between. If I had a whiteboard, I'm not used to doing lectures on Zoom, but so you get 68% of the data is within one standard deviation, and then you get 95% of the data within two standard deviations. And so what they've shown here is 2 standard deviations above the mean and 2 standard deviations below the mean. That's what those dotted lines are. And so they're saying, even in this sort of confidence interval, we are above 0. Almost always. It does dip a bit below, but you see how the confidence intervals are largely above 0. Now, it would be concerning if the confidence interval in the bottom was for a large part below 0, right? Then we're essentially saying that difference is not, that could be due to chance, okay? So this idea about standard deviation is important when you're talking about data. So the mean, the key point here, big picture takeaway, is that the mean of 2 groups is not enough, is not sufficient to tell us anything. You need to know about the standard deviation. And that's, remember, a measure of dispersion of the data. We talked about these 2 examples where there's completely no dispersion, and then when there's a lot of dispersion, right? Cool. So the main results of this paper, and so remember, they didn't have data on whether the children or whether these people have ADHD or have any disease. All they have data on are the prescription drugs. So you have to take this as a proxy for, a proxy just means like in lieu of, a proxy for these diseases, that there's a 25% rise in the likelihood of using ADHD medication. I find that very stunning kind of result. And then, later on in life, these effects persist for anxiety, depression, etc. And as we said, based on how close in the family tie sense the relative is, the stress is increased and the effects are higher. So what does this tell us? This tells us that basically we should be investing a lot in keeping pregnant mothers as safe as possible. And the authors point to many pregnant mothers in poverty are likely experiencing many of these stressors and are causing a sort of feedback loop that's keeping many people in poverty. And I'm sure now they're suggesting that, and it does sound theoretically true, but that's another paper. And I'm sure these authors are trying to write that paper like right now about poverty and its sort of cyclical effects using some in utero shocks. Cool. So any questions on this? So this is a very dense paper, but I think that the main results are very interesting, and hopefully you guys learned something.
I had a question. So I guess it's kind of hard for me. Well, I was really confused on how they were able to prove it as a causation, just because it's a quasi experiment. And I know, like, even in real life, you can never get ideal conditions. So then how do
Great
they
question.
reconcile that?
So great question. So how are they arguing that this is causal? The reason is they're comparing, they have incredibly deep data for, I think it's every single person in Sweden. I think that's the data set. So it's not even a sample. It's the population of Sweden that they have going, long window. And what they're comparing is they're comparing cohorts that are the same in many measures. They're controlling for, say, socioeconomic status. They're controlling for all of these things that could cause any sort of difference. And then after they've done all these controls, there's one difference in the groups. And that's that one of them gets these in utero shock and the other does not. So that's how they're pointing their arrow of causality, right?
Okay.
And this is the assumption here in the bottom, is that this timing of the death is not correlated with any of these determinants of child well-being, like socioeconomic status, et cetera, et cetera. Good question. Cool. Okay, so I think that's all we have to talk about. I think for some of the new students here, I'm going to answer some questions regarding